मेरी स्क्रीन सबको दिख रही है? हेलो मधुवंती, गणेश? यस ना? ओके.
Yes, sir.
Okay. Today we will consider our first lecture. Okay. And by discussing that first lecture, we will start with syllabus discussion and the course outcomes according to that. Okay. Uh, This is the syllabus for Ubiquitous computing. It is mandatory course for you as a SPPU's syllabus, fourth year of information technology. 3 hours per week lecture scheme is there, or teaching scheme. And examination scheme, you will have around 30 marks of in-sem and 70 marks of end-sem. The prerequisite for this is CI. You must know how exactly human-computer interaction takes place. You have already studied that particular subject, right, in third year. CNT, so computer network is required to understand how exactly the systems or components will work in ubiquitous computing. When we are discussing about the course objectives and course outcomes about this subject, right? So the SPP has defined some course objectives. The course objectives are initially to describe what is meant by, first of all, ubiquitous computing. You must know, first of all, what is ubiquitous computing, what are its properties, what are its applications, and what are its basic architectural design. So here we will understand the definition of ubiquitous computing, five different kinds of properties of ubiquitous computing, the applications of ubiquitous computing, where exactly it will be getting applicable or currently in current user scenario, and then architectural design. So here we will explain in detail different kinds of smart devices. So second objective is our to explain various smart devices and services used in ubiquitous computing. So we will discuss here what are the different smart devices are available and why exactly these devices are called smart. Okay, by means of understanding their working and their functionalities implementations and what kind of services they are providing. Okay, then third objective is to teach the role of the sensors. So what exactly the role of the sensors and actuators when we are designing the real-time applications? That is also called as what exactly we called Ubicom systems. So Ubicom system is short name is there. It is known as Ubicom only. Okay, so UBICOMP, Ubicomp. So Ubicom systems will be there. So in real-time systems, what is the role of sensors and actuators we require to understand? Okay, so we'll discuss in detail in unit number 3 in detail. Okay, so what are the different types of sensors, and then what are the actuators, what are the MIMS or MEMS, right? So we will discuss that MEMS and all those devices kinds of things and their properties, their architecture in detail. Like we can say that the tags are there. So we will discuss the tags, different kinds of tags, active tag, passive tags, etc., and their scenarios of applications. Along with that, we will discuss how exactly these tags are working and all those things. Okay, so one by one we'll discuss about it in one by one units. In fourth number objective, we are exploring how exactly interaction takes place between with ecom systems. Okay, so how interaction takes place, that means user, how exactly user is interacting with computer. Now it may possible that to complete the goal of the system or to complete the whatever exactly expected goal, we require to understand the interaction in between the systems, maybe computer one computer systems to another computer system, or maybe the users with the computer systems, or from computer systems to users as an response or as an intimation, right? Whatever exactly it is. So we will discuss here the number of degrees of interactions, human to computer, computer to human, right? So that is known as SCI to CHI, like that. Then we can also discuss that human to human computer interaction, computer to computer interactions, right? So there are different kinds of combinations we can have, which we will discuss in detail one by one in the fifth number unit or fourth number unit. In detail we'll discuss that particular in fourth number unit. Okay, so then to explain ubicom privacy, so we will discuss in unit 5 what is meant by, first of all, the privacy and what are the different kinds of challenges in their privacy to maintain the privacy basically. Okay, and for this we will use another different kinds of books. Okay, so we'll discuss the textbooks also. So to achieve this objective we have to use another book, fifth number objective. The sixth number objective is to describe the Ubicom network with design issues and Ubicom management systems. Okay, so in six number objective, we'll discuss about what are the available networks are there which are supporting for Ubicom system applications, and what are the emerging networks also, right? So you know that PAN is there, Bluetooth is there, right? So number of different kinds of LAN, WAN, PAN, whatever exactly you are, you know the number of these ways of communication through network, right? So internet now available everywhere. So ubiquitous, the term itself says that it is everywhere. So anywhere computing is nothing but the ubiquitous computing. Anywhere computing is nothing but ubiquitous computing. Okay. So here we are discussing that six number unit is for the purpose of different UVCOM system managements, how exactly it happens in networks. Okay, so this is course objectives. When you will achieve these course objectives, every student at the end of this course will be able to demonstrate the knowledge of design of UVCOM systems and its applications. So how exactly we'll demonstrate? So for that, again, we will have an enjoyable learning activity that in enjoyable learning activity, you have to prepare one model or poster, digital poster, simple way. In digital poster, you have to prepare the one Ubicom systems architecture and the application scenario of that particular Ubicom system. So for that, you have to prepare one group, and through group, you have to suggest one application where exactly what kind of network is using, what kind of different components like sensors, tags, or actuators you are using, and what is the design, right? So how exactly it is working, so, and then its applications of that particular Ubicom systems, right? So that particular design you have to represent as a digital poster here as a outcome of this course, right? So after getting first three units, then we will take one our enjoyable learning activity, and according to that, you will present your model, digital poster presentation on any Ubicom system. So start from today itself. Understand there are so many different internet resources are available for understanding Ubicom systems. Take one in Ubicom system which will have the architectural component, so that you can understand, you can explain it better, and then its applications. Okay, so it can be in group. You have to submit it. That is what exactly we are considering the term work submission for this. Okay, then explain smart devices and services used Ubicom systems. So through that particular digital poster presentations, you will explain what are the smart devices you have used, what are the different services are there. We can categorize that services if you want. Otherwise, you can explain these are the services for this kind of Ubicom system applications. You have to understand what is the significance of which actuator, which controller, where exactly the real-time applications are there. That is the end of the course. You will understand it. Then you will understand the concept of HCI from the design's perspective, and to make the applications automatically, right? So you will understand the human-computer interaction to understand particular design of automation of those applications, and then you may able to classify different kinds of privacies and the challenges associated in that particular privacy, maintaining privacy basically. Okay, and at last you will understand the network management in Ubicom system application. So this is course outcomes are there, but by understanding the concept of Ubicom systems syllabus, which is given by SPPU, the course owner, that means myself, I have designed some our course outcomes by considering some Bloom's taxonomy. Okay, and by considering that Bloom's taxonomy, we have defined our course outcome statements like this. Every year, we are calculating the course outcome by understanding how much the students are understood from unit test, how much they get marks, how much in same they get marks, and for end same they have achieved the marks. So by understanding that particular perspective, we are achieving the course outcomes. So initially we are deciding that course outcomes are having threshold of 100, maximum 100. Okay, and for each and every teaching activity or assessment method, we can say that we are having some grades. Okay, so we are designing. So 50% internal evaluation and 50% for external evaluation we are doing for achieving the course outcomes. So in 50% of internal assessment, we are doing some unit tests, some enjoyable learning activities. Like right now, we have told to you that digital poster presentations, some assignments, theory assignments we are giving to you, and your response to that particular assignments. Okay, so how much you have understood that? So your understanding can be measurable through unit test marks, in same marks, and end same marks. So in same and end same, we are considering the external, okay, assessment, which is based on the university marks, right? And internal assessment we are giving based on unit tests, assignments, theory assignments, and enjoyable learning activities. Okay, so according to this, we are achieving our course outcome for every course. So our first course outcome statement says us that students will be able to demonstrate the knowledge of design of Ubicom computing and its applications. So after understanding Ubicom systems design, you have to explain what is the architecture. In architecture, you must know the knowledge, what are the different components are there, and different Ubicom systems computing applications. You must be able to demonstrate. So this activity, or sorry, this course outcome can be mapped to digital poster presentations as well as unit test and all those. Students will be able to explain smart devices and services used in Ubicom systems. Students will be able to describe the significance of actuators and controls in real-time application designs. Students will be able to use the concept of HCI to understand the design of automation applications. Students will be able to classify Ubicom privacy and explain the challenges associated with the Ubicom privacy. And student will be able to classify type of service oriented networks to manage Ubicom systems. So you can see the course outcomes of USPPU statements we have kept as it is, but we have mapped it with the help of our program outcomes. There are 12 program outcomes are there and 2 program specific outcomes are there. Okay, so what are the different kinds of program outcomes and program specific outcomes? So we have displayed you. Okay, so these are the graduate attributes which are suggested by the AICT and UGC norms. Okay, so these are the attainments in previous year. So 90% plus the achievement is there, and based on the attainment level of more than 60%, the attainment level is 3. Okay, so wherever we are achieving 3, that means we are decided that the attainment level is most highestly achieved by the students. Okay, so you can see that map level weightage is given here and how exactly we are calculating. So this is for reference to you that we have assigned for what course outcomes and what are the different kinds of mappings are takes place. Okay, so now we are discussing about unit-wise importance of this in this course. So unit 1 is basically introduction of ubiquitous computing. You can see here for every unit we require at least 7 hours to complete the course. So that means 6 unit into 7, 42 lectures we required. Okay. So unit 1 basically gives what is the basic ubiquitous computing and its advantages, the properties of ubiquitous computing, the applications of ubiquitous computing. There are 5 properties are there. We will discuss those in detail one by one. Okay, and then we are having the modeling key computing applications, modeling key ubiquitous computing properties. Basically, 5 properties are there. Okay, so here, uh, okay, okay. So here we are discussing what are the basic key properties are there. So 5 properties are there. We will discuss one by one, like distributed, autonomy, right? Autonomous, automatically it should be done. Okay. So we'll discuss 5 different properties one by one in detail. That means context awareness is required. I would like to give some examples of ubiquitous computing applications. For example, many times you entered into the mall, automatic door is open. So whatever the glass door is there, it is based on sensors. It is automatically open, right? So whenever the user coming to that particular door, automatically gets open. So that is what exactly context aware. So it is understanding the movement. So the sensors will capture the movement of the users, and based on the distance covered, right? So if it is coming to that particular door, automatically the door gets open. So functionality of door is based on the sensor information. So sensor information about the user movement and the distance calculated according to that. Okay. So this is one example of ubiquitous computing. So there are so many different examples are there in ubiquitous computing. Whenever you will go that with the help of claps, you can start the lights or stop the lights, right? So with the help of biometric different kinds of recognition devices are there, right? So through that also the doors can open. For example, you may have if you are working internships in the company, you may get the access of that particular company through your digital card or whatever the tag based card, we can say that, right? uh, in malls also the some what we can say that the atoms are tagged, and according to base of that particular tag, now it may be whatever exactly barcode or whatever exactly the tag is, or it may be sensors, right? So through that automatically the atoms will get calculated, its price will get calculated, right? So there are so many different kinds of applications are there in ubiquitous computings. Okay, so ubiquitous computing, we will understand that particular properties in detail with the five different kinds of properties. Okay, we'll see one by one today. Then we will discuss about the interaction and architecture diagram. So basically here we'll discuss smart day model, that is design, environment, and interaction model. So design is for devices. Okay, so device, environment, and interaction model basically it is. So you are using devices in the ubiquitous computing environment, and with the help of user or HCI or CCI, whatever exactly interactions you are using in that particular based on applications, your architecture will be prepared. Okay, so we'll discuss in detail what is the role of devices, what is the role of environment, and what is the role of interactions in this smart day model of Unicom systems, where exactly it is also called as architectural design. Okay, for Unicom systems. So we'll discuss in detail that. That is unit number one. Unit number two, you can see here the ubiquitous computing and smart devices. So we'll discuss all devices, their properties, which kind of services they are providing. Like we can say that the mobiles, right? So mobiles are the one of the examples of the smart devices. Smart cards are there. You may be having some cards like for access for your company, for bank, ATM cards, digital cards, or credit cards. Other than different cards are also available. Okay, so some tags are pasted on your vehicles also to understand that whether your vehicle entry point as well as exit point, when exactly it is entered, when exactly exited, right? So in companies or in malls or in many times in access mechanisms that can be utilized for vehicles also the vehicles are having the tags, and based on the tags, maybe it may be active tags or passive tags are there. We'll discuss one by one. So which is required energy and which is not required energy, based on that particular tags are created. So the tags can be utilized on vehicles to understand the transport purpose, right? So for example, if the you have prepared one tag and it is associated with truck, and you can understand where exactly the goods position is around. For example, suppose you are demanding or you have sent request for the Tata new car, any Tata new car, and if it is manufacturing places in Delhi, or right, and it will shipped from Delhi to Maharashtra. So, what is the current shipment of address or current status of shipment? You can get it through that particular tag-based information. So, whatever the tags is associated with that particular goods, right? So, for example, that car, the tag can be associated, and we can check it out in transport from where location, where exactly from source destination it was forwarded, and when its current position is there. And by calculating the time period, and according to that we can understand or estimate when exactly it will reach its destination, right? So if anything else happens, that can be considered. If anything else happens, that can be considered that something has happened due to some interactions, and then mitigation and monitoring report and management information can be takes place. So all these things can be happen one by one, so we can just understand that whether we will get it correct on time that particular goods or not. So this is one example I'm just giving you. So there are so many different examples are there where exactly you may consider that the UVCOM systems can get applications. So we are discussing like devices. So that device can be applicable here. Okay. So mobile codes are there, or smart codes and networks are there, smart card devices and networks. Service architecture models are there. So here exactly basic uh, from the perspective of the university syllabus and university exam, we have to understand what is service provision life cycle, when exactly service is announced by the service providers, and some consumers of that particular service will subscribe that particular service, right? So subscription and publication models, right? So subscriber and publisher model is there, as you know that, or the consumer and producer problem, you know that concept. Okay, so that kind of life cycle we'll discuss of service oriented in terms of service provision life cycle. And at last, there is one term is there, virtual machines and operating systems, right? So there are some virtual devices are also there, and some virtual operating systems are also there, right? So those can be utilized for making communication with the other devices. So that short notes will be appearing, so you must study that particular virtual machines. So in virtualization of cloud computing, you have already studied that. Okay. Now, uh, unit number 3, based on the tags, right? Acquisition and control. Again, 7 hours are required. Here we'll discuss what is meant by tagging in detail, the types of tags and all those things. Okay. Then we will discuss here the concepts of MEMS, that is micro electromechanical systems, right? And we will discuss different types of accuracy control systems are there. So smart dust is there, right? So smart dust, smart walls, smart paint. Okay, so all these things are available here. So we'll discuss in devices basically, but their basic architecture or their components we'll discuss in MEMS, right? Okay, so for example, we'll have an ubiquitous system example, that for example we can have paint, smart paint is there. So if you are giving smart paint to your wall, the smart paint will consist smart small particles of the what we can say that the nanoparticles, which are able to communicate with each other, which will send some kind of information and share that information with their neighbors. And in such a way, the aggregated nodes will collect the information and they will send it to the one of the what we can sensor node is there, and then sensor node will grab that information. It will analyze what kind of information is there, and based on that the functionality can be done. Okay, so this can also be happen, this can also happen with the help of the MEMS, right? So smart dust, smart paints, right? And smart walls are there, so to detect the temperature, to detect humidity and all those things, to detect sunlight and all those things. So some sensors can be utilized, and on the basis of that some operations can also be done. Some projectors can also be worked out with the help of smart dust, smart paints, or smart walls are there. Smart walls can be utilized for the purpose of displays also, right? So we can utilize it based on our concepts, right? So what sensors and what actuators we are using, based on that what kind of systems or devices we are using, based on that the applications are there. So there are different kinds of embedded systems are there, and real-time systems are also there. For example, we can have the pacemakers, right, in our heart. So these pacemakers are example of embedded systems. We are embedding it into our body. So different kinds of what we can say that the devices are there, those can be embedded into different other systems, or real-time systems are also there. Basically these real-time systems in aeroplane they are using for the purpose of maybe identifying the current location of the airplane, maybe the source, destination, and path, or maybe the current weather and all other different kinds of information is required, and communicate through the centralized locations, right? So real-time systems, RTS, and for that RTOS is also there. Real-time operating systems are also working there. So there may be some devices which can be programmable, right? And they can take the control of the systems. Okay, so we'll discuss that particular PID types in detail in unit number 3. And we'll have one simple robot example, right? How exactly robots are working. So for short note, if theoretical exam will be there, then short note will be given on robots. Then unit number 4 is there, based on the human computer interaction. Now, this human-computer interaction basically has number of different kinds of interactions. We have discussed that human-to-human interaction will be there for making interactions and giving and inputs and providing the outputs, like kind of things, or sharing the data, sharing the information, or kind of things, or sharing the responses, kind of things. For that purpose, interaction is takes place. But to complete the automation systems of any applications, we require to introduce computing systems also. And the users need to communicate with the computing systems, and computing systems may also interact with the users. Based on the response of the users and response from the system, human and computers may take decisions. Correct. So there are, what are the different kinds of interaction devices are there? What are the different kinds of user interfaces are there? We'll discuss in detail along with what is the basic architecture it is utilized, what is the human-centered design is there, right? Based on that, what is the, we can say that the smart variable implanted devices are there through which the communication will take place. For example, suppose some person has paralyzed their hand, and to note their finger movements, or to provide the, what we can say that the one therapy is there, right? So to provide that particular therapy, it may possible that some wearable devices can wear on that particular fingers or a hand, and they may continuously sensing the information of the finger movement or hand movement, and according to that some PID controls can be utilized which will control the finger movement, and they will give some exercise, they will give some exercise to their fingers and all those. Okay, so this can also be happen with the help of what we can say that the wearable devices. Implanted devices, I was given already example of pacemaker. In body also you can implant some kind of sensors, or some tags can be inserted also, right? So based on whether they are supported for body or not, and all those things, as you know that. So that means there are so many constraints are there when we are embedding or implanting the devices, or we can also wear the devices because it should not harm to the body, right? So by considering that aspects also, we have to consider number of different kinds of user interfaces, the material used for that particular design, and when it is actually in use, whether it should not harm the body or the person who is wearing it, that particular thing, right? So it should not be harmful. And by considering the systems interactions, the humans are centralized design. So by considering humans is centralized user interface, we will design our systems in such a way that the response from the user is expected, what kind of response is expected from system, and what kind of response from the users, and it should be human driven system, right? Or it many times what happens, the controls should not drive the users, or the systems should not drive the users, but users should drive that particular system. Okay, so that kind of control nature we have to provide, and for that purpose we have to understand different kinds of user models, right? User input models, user output models, we will discuss in detail. Then what are the modeling users planned task will be there, and multiple task based computing need to be understood. I will have to give the example of control design means what exactly, how exactly user will get controlled by system, and system will get controlled by user. In aeroplane, there is two different modes are there to operate that particular aeroplane. One is manual mode and another one is automatic mode. So in automatic mode, once you have given the direction and the source and destinations, right? The automatic mode for that aeroplane will be decided the direction, and it will continue with that particular direction with the height, how much height it should be there, and according to speed also, what much speed should be there. So once it is decided, automatically the machines will work and it will perform the actions. But if anything goes failed, right, and if the control is not given to user, then it may possible that the whatever the consequences will be there, maybe whatever exactly crashing of aeroplane or the other consequences, we can say that. So to handle that particular consequences later on, instead of that, the control must be directly given to the user, so it should be manually operated, right? So both modes are given there, right? So for the purpose of landing and for the purpose of taking off, the manual intervention is required. So the direct and indirect user, as that in that way we are considering what is the input and output is there, right? So there must be some planned tasks are there, So through that particular plan only, from source to destination, the plane must take off and take directions, right? And it should be fly in that particular directions only. And it will reach the destination with that particular, but there will be some manual intervention is required, right? And if it is totally controlled by the system, then it is not happening. So it may possible that the system may interpret in wrong way the input is provided. If one of the system failure, component failure, then system may behave differently as per the different goals, right? So if the goal is not achieved, then it will be problem for us. So here we will discuss the basic computer interaction and their degrees of interactions and their impacts of interactions, and what care need to be taken while designing that particular interaction with the help of user interface interaction and human-centered design, and understanding the modeling, input and output modeling, okay, and task-based modeling is there. So unit number 5 is there, basically based on the privacy, Ubiquitous systems privacy. The first 4 units, see, you can see here the textbooks are there. So textbook consists, first one is Stephen Puslat books, that is Ubiquitous computing book. It is a Willy publication book, and all out of 6 units, only fifth one number unit will be considered from our second number book, that is known as John Crumb's Ubiquitous Computing Fundamentals. So this is second number book. The first one is the Stephen Puslat Ubiquitous Computing, Willy publications. The second book is John Crumb's Ubiquitous Computing Fundamentals. So all 5 units, all first 4 units and sixth number unit can be studied in detail with the textbook Stephen Puslat. Okay, all components are available there, all concepts are available there. But for unit number 5, that is Ubiquitous Computing Privacy, you may utilize the John Crumb's Ubiquitous Computing Fundamentals book. Okay, where exactly you will understand what is the definition of privacy, because privacy is defined by so many different authors, right? Inventors, we can say that, or different organizations also they have defined. So we'll discuss basically the authorized privacy definition. We'll discuss from the Sol's perspective what is the taxonomy of the privacy. So many times the questions were asked on Sol's taxonomy of privacy. The legal ground, like background basically. So what are the legal laws are there to maintain the privacy? Okay, and to maintain that means to keep the interpersonal privacy. Many times what happens, the friends are there. These friends are there, basically these friends are sharing their personal things with the friends, and it may possible that the friends may publicize it, right? So it should not happen. Which information should be publicized, which information should not be publicized? So many times, one example I would like to tell you, whenever you are registering for any service on, maybe it is Google or maybe it is another online, registration page has one statement that this information is utilized with the sister concern organizations of this and that, and for that purpose we will use only this information, right? And you are need to check it. That means you are need to provide access to that particular information, and you are agreeing that that information will be given to them, so and they will utilize for this. So many times whenever you are doing such kind of aggregations, by checking it and by accepting that aggregation, or whatever exactly we can say that the agreement basically. Okay, so that agreement is considered that you have understood your information may be shared with these different kinds of entities of that particular system concern industry or organization. Right. So here the interpersonal privacy has some legal rules and regulations. We'll discuss that in detail. Then, whenever we are considering that the privacy has to maintain, first of all, we require to understand. For example, if you are doing any kind of registration on Google, all information is with Google. So what are the different means are there? By means are there that particular private information will get publicized or will get distributed to all other persons. Those are non-intended purpose, right? So maybe some malicious users may do that particular thing, right? So what are the different ways are there by which that private information is getting collected? So the collection scale, right? So maybe it is large, maybe it is medium level, maybe it is higher level, right? So like that, the collection scale, the collection manner by which the information will get collected, and for what purpose that information is getting collected, that is motivation for collection of that information. then in which kind of format that information need to be getting collected, and what are the data accessibility rules and regulations are there. Okay, so all these things need to be understand to maintain the challenge of the privacy. Okay, so here we'll discuss one case study, that is protecting RFID tags, how to protect RFID tags by means of privacy, and ways of addressing privacies in UVCOM systems. We'll discuss in detail. This is unit number 5 is there. Okay, now we'll discuss at last how that unit number 6 is there. That unit number 6 is based on the communication and management systems. So the data networks are there. So different kinds of data networks, you know, that GPRS and 2G, 3G, 4G, whatever exactly. Audio networks are there, right? So wireless data networks are there. Ubiquitous computing networks are there. Service-oriented networks. You know the concept of SOA, service-oriented architecture, and service-oriented services, right? So we can say that all services which are provided through service-oriented architecture, like web-based architecture is there, right? So you may have that particular internet facility is one of the example of that. Maybe you are having some kind of email services or other different kinds of servers, those are provided you the services. Maybe we can say that the share in share market, if you are considering, if you are subscribed for different kinds of inputs, right? So for example, tips are there, and daily tips you will get it. So initially you have to subscribe it, right? So publisher will publish its service, and subscriber will subscribe that particular service. So based on that, these service need to be getting maintained, right? So then there are different kinds of network design issues may be there. The issues related with how to configure and maintain security of the networks, will be there. Then how to manage the information associated in that particular networks. Okay, so service oriented computer and information management has to maintain, and the concept of context awareness is there. So all our systems must be context aware, right? So this is what we require to maintain by the systems automatically or through some agreement, service level agreement. So SLS has to be maintained, right? And according to that, it will be provided. So this is what we will discuss in detail, communication and management systems in detail in unit number 6. So we'll have two different kinds of books here: Stephen Pusla's Ubiquitous Computing Wheelie Publication and John Crumb's Ubiquitous Computing Fundamentals. I already shared these books on your classroom. Okay, so here the classrooms are there in textbooks. You can see here Willy publication book is there. So I already opened that particular book here. This is Stephen Pusla's book. You can understand, right? So starting from the contents, ubiquitous computing basics, their applications, 5 properties, right? Then architectural design, that is their model is available. So you can see unit number 1 and 2 will be, chapter number 1 and 2 will be for unit 1 is there. So start learning from this UBCOM system, okay? Kindly meet and visit the class every time. Okay, so the syllabus is also available. Unit 1 study material along with the PPTs are provided in terms of PowerPoints are there. Now whatever our lectures are will be recorded, those lectures will be also provided on your classroom. So attendance is mandatory. If the attendance is less, then we'll reschedule the lecture in evening sessions. So those are in doing internships and all those can also attend the lectures. Okay. Okay, so there are, it is very interesting subject is there. It is along with your understanding of the current situations, right? In current situation applications. Okay, so yeah, right now you are getting your COVID report at home itself by using this managing the communication management networks with the help of associated with your just Aadhaar card number. Any information can be provided to you. Verification can also be done with the help of Aadhaar base, right? So the so many different kinds of Ubicom system services are there. So the term ubiquitous is known as anywhere, anytime. The computing adds it's that anywhere, anytime will have the computing, right? So what kind of computing depends upon the scenario application scenario, right? And we can apply for that. We will have some kind of portable devices, and those devices need to maintain the communication with the networks. Then and then only the applications will work out, right? So we have to understand what are the different systems, what are the different devices, what are the different services we can provide through this Ubicom networks and Ubicom computing systems, so that So many different kinds of applications can be achieved with the help of these EVCOM systems. Okay, so we'll understand it in detail one by one in our further lectures. If any questions are there, please let me know.